Ephemeral apps. Let me start by asking you a question. If you search St. Augustine, Florida on Google Play Store, you'll probably see 67 apps or 68 apps, depending upon when you search. How many did you try or even looked at? So the question that we're trying to ask is, if relevant apps came to you, popped up on your home screen, and you didn't have to install them to try them, would you have tried any? I don't know the answer, but that's what this research is about. Uh, More formally or concretely, what is known as app discovery problem. Out of 1.75 million, which is increasing rapidly, apps available on Google Play Store, only 10% of those are downloaded more than 5,000 times. And this presents a grave concern for app developer community because newer developers can't really get to people, and of course users who might like or might find useful those apps don't get to use those apps. App discovery is actually a two-part problem. One is, as probably the issue with all the work that we discussed, like contextual app classification. How do you identify the right app for the right person at the right time with all the context available? And another one is basically how much effort does it take for you, even if you know the app, to actually use it? So this is the first question that we asked, and the graph on the left-hand side shows a CDF of time taken to install top 5,000 Android apps which are available freely from a local machine, and that goes from like 2 seconds to some of the apps could take like 16, 17 seconds. And if I have to wait, I mean, personally, if I have to wait for 10 seconds or 8 seconds for an app to install, I'll probably not use it. This is the focus of this work. I believe that there's a lot of work that has gone into contextual app classification in terms of recommendation engines and app suggesting engines that app stores already employ. So this builds on top of it. So let me just first clarify, what are ephemeral apps? Title doesn't give too much away, apart from you probably think Snapchat, but this is not what I mean. So this is a picture where you have a new home screen where there are no apps. I don't know if it's visible. So you enter a context. Say, for example, you connect to a particular Wi-Fi network. Apps start appearing on your phone, and you have those apps. You use them, you get out of that context or disconnect from that Wi-Fi network, and those apps are gone. This is what I mean by ephemeral. And gone means all the code that app requires to execute, any state that it modifies on your phone or creates on your phone is all gone. And you might want to, like, it depends on user preference whether you want to sync it to a backend data center or backend service or not. But that's, I actually had a video, but it was not playing well for me for last few times, and so I decided to go with photos. In order to make that possible, what it requires is the phone and a lot of changes in the mobile operating system to support the kind of execution that is required for ephemeral apps, and then an e-box, what I like to call it, or you could, it's basically something that is situated at the edge. It might be a Wi-Fi router, maybe a cloudlet server. Yeah, cloudlet server, anything. Yeah, edge box, whatever. Yeah. So I don't call it cloudlet because cloudlet is conventionally used for server-side data center type thing. That's why. This is what the vision of ephemeral apps is. Currently, app developers submit apps to app stores, and users install those apps on their devices and then use them. How I see, or how we propose how this can work out is, these apps are still submitted to app stores because they do like important tasks of auditing and sort of security checking of those apps, and then they could be pushed out to the cloudlet infrastructure or any other vending machines or sort of like hotels location and something like that. And then they reside on this edge infrastructure from where they can be presented to end users as and when they come in proximity or based on any other context. And then apps can be directly streamed off to their devices while execution and then can be removed. So before going into the challenges and technical details, I would like to discuss what are the goals of like developing this support. First and foremost, it's convenience. I don't want to go to App Store, search for app, install it, and run it, and then I forget about uninstalling it if I don't use it. It keeps updating for no reason, or it leaks private information or whatnot. Second is if any new sort of or type of app is introduced, it should not suck at performance. Otherwise, no one is going to use it, and that's what happened. Like, not happened, but that's what sort of moved native apps above web apps at like a little while ago. And finally, need to access native device features is another important constraint that HTML apps or web apps have been facing for a long time. But about the properties of these ephemeral apps, we want them to be instant. Like, it should not take like 5 minutes to populate apps on your phone. Otherwise, you can go to an app store and install it anyways. So this rules out the possibility of when you come in a context, just push all those apps on your phone, and then you can use them. And they need to be transient in a way that the user device is kept clear of the app code itself, any state that app modifies or creates on the end user device. So one way to go about it is ask all the developers to do their apps so that they work in a streaming fashion, or in other words, have a SDK or Java SDK or something like that, and ask developers to redo their apps. So this is the constraint we put on our research. That we don't want this, because it's really hard to mobilize a app ecosystem. Probably that led to a lot of like death of most of the other app ecosystems apart from iOS and Android. And the second one is you could ask users to change his behavior, and that is something that we did not like sort of aim for. So let's talk about the challenges of designing such app ecosystem. So what support do we need from mobile systems? Mobile operating systems needs to handle all sorts of different kinds of apps and different kinds of app components they contain. There needs to be currently how app integrity is established is based on developer signature. That is done on a full complete package. So that needs to be augmented to be able to verify integrity at individual app component level. App sandboxing, as in all apps in iOS or Android run in a sandbox. So you don't want to break sandbox while you stream those apps. Permissions, right now, like install model sort of mandates that you basically agree to or disagree with permissions that app requires. And finally, tracking and deleting or managing app state. On the Play Store side, you need to make sure that it is well integrated with app stores. User trust model, because in a way, as end users, we trust native apps more than web apps or websites that we visit. And finally, user privacy, because once you know what app components are being fetched for a particular app, you can very easily infer what user is trying to do with that app. In terms of server, you basically need to have an app streaming server at somewhere, like at some location, probably cloudlet. And finally, you need mechanisms to manage app repositories. And there have been our previous work that actually talked about that. What choices do we actually have to design this system? We have a tall mobile OS stack. You can sort of have an indirection at any of these layers to enable this app streaming functionality. At Linux kernel level, there could be you could be remoting pages. At libraries or runtime level, you could be remoting Java heaps, and at an application framework layer is what we chose to do, because most of the functionality an app actually executes is it comprises of this application framework libraries, runtime, and Linux, apart from its own source code. The second choice that we had was, where exactly do you put this edge sort of ephemeral app server? You could put that in remote cloud. You could put that in CDN servers, or you could put that in the cloudlet servers. So that is the question that we were trying to be like, haven't really got to a answer to that, but it seems that cloudlet does give similar performance as native apps. Or you could simply have use other forms of app that exist now. You could use web apps or thin clients, and everybody knows or agrees that web apps is the future. I sort of don't, but that's a question that. So in terms of design, there's a lot of design that went into how do you what changes do you need in mobile OS, specifically Android, for which it was prototyped, and how do you design ephemeral app server. So not to get into details, you can refer to the paper for it. The key ideas is you need to decouple app presentation from app execution. And second is ephemeral app server needs mobile OS specific tools to have that app repository and serve appropriate things. But you might ask, what is new about this? Yeah, you have a client, you have a server that streams executable. Yeah, big deal. So there are 4 key points that I want to highlight. One is ab initio app streaming, sort of to run ephemeral apps without having any prior knowledge about those apps. Runtime integrity check that I already talked about. You need to check for individual app components. Runtime permissions to run ephemeral apps without actually prior approvals. This was something also proposed by Google, but I didn't get accepted before that, so it's there now. Anyways, and finally, app ephemerality, that to remove ephemeral apps and their state, you need to track what they do during their execution when they execute. In terms of workload, I made those changes to Android Lollipop. We used eBox or Cloudlet as a Linksys WRT 1900 AC router. I used unmodified apps as the apps that got served. 40 top free apps from Google Play Store and Facebook, Chrome, Edge. Not primarily because you're going to use Facebook as an ephemeral app, because it's the most complicated app that exists on App Store. So if you get it running, you probably have most apps running anyways. And because these exercise a specific kind of resource that I needed to watch. So just by running these, and I just want to say that we can use unmodified native apps as ephemeral apps, sort of a middle ground between web apps and native apps. In terms of measurements, what we did was we measured how much time does it take for an app to install from a local machine and then launch versus an ephemeral app launch. And it turns out that the red diamonds are the installation times, and red crosses are launch times of native apps, and the black dots are ephemeral app launch. So we're pretty close to native app launches. It just goes on to state that if you are presenting apps in this way, you might have lower times or any lower efforts for end users to use those apps. As next steps of this project, we're working on finishing this implementation and evaluation. I'm looking at a use case where I could use ephemeral app as configurations in multi-device interactions to provide zero conf interactions in IoT scenarios. And finally, on a more sort of theoretical side, I'm looking at what it means for ephemerality as a system property, and what would it take to support it in the OS itself, as opposed to apps like Snapchat and Secret. Thank you.